Hi everyone, welcome to CodeTav Management. This is the continuation for the Solid Principle playlist. So we have covered with the S for the single responsibility principle and O for the open closed principle, and also L for the Liskov substitution principle. So now this is for the I, which is interface segregation principle. Okay. So if you review your project code thoroughly, so you will find that this principle is the most violated just because we don't focus on the good design while coding, right? So the interface segregation principle says that that clients should not be forced to depend upon interfaces that uh, they do not use. Okay, so when we have non-cohesive interfaces, the interface segregation principle guides us to create multiple smaller cohesive interfaces. So larger interfaces should be split into the smaller parts or smaller interfaces, and by doing so, we can ensure that implementing classes only needs to be concerned about the methods that are of interest to them. So a client, no matter what, should never be forced to implement an interface that it doesn't use, or the client shouldn't forced to depend on any method, so which is not used by them. So basically, the interface segregation principles uh, tells that it preferred the smaller interface, okay, which are small but client specific instead of monolithic or bigger interfaces. Okay, so for that things, after doing that kinds of uh, usage, you can say like in respect to the microservice architecture, we use these things, and which is good practice. So in short, it would be bad for you to force the client to depend on a certain thing which they don't need, right? So when you apply this interface segregation principle, so classes and their dependencies communicate using the tightly focused interfaces, minimizing the dependencies on unused members and reducing the coupling accordingly. So smaller interfaces are easier to implement, improving flexibility and the possibility to reuse. As fewer classes share these interfaces, the number of changes that are required in response to an interface modification is lowered, which increases robustness. Okay, so basically, the main thumb rule is here. So don't depend on the things you don't need, right? So now I will show you like when the code violates the interface segregation principle. So let's assume that there is a restaurant interface, okay, and it takes orders from the online customers, telephone customers, as well as the walk-in customers, okay, and it also contains methods for handling the online payments for the online customers and in-person payments for the in-person customers, right? So telephone customers pay in person at the time of the order delivery. So now let's create a Java interface for the restaurant and name it as the restaurant interface.java. So we have created this restaurant interface, and inside that, these methods are there. First one is accept online order, then accept telephone order, then accept walk-in customer order. These are for the order system. And for payment, this pay online and pay in person. Okay, these two. So we have these 5 methods in the restaurant interface, and therefore accepting the online order, taking a telephonic order, and accepting orders from the walk-in customer in order to place the order. So similarly, accepting online payment and accepting payment in person in order to make the payments. So let's start by implementing the restaurant interface for online customers as the online customer IML. Okay. So this online customer IML implements the restaurant interface. So inside that, this accept online order method implementation is there. Inside that, you can write the logic. For the telephone order also is there. For the pay online is also there. And also this accept walk-in customer order and pay in person. These are not for the online, right? So that's why we need to throw the exception, which is like unsupported operation exception. So as the online customer IMPL dot Java, this is for the online customers. So we'll have to throw this unsupported operation exception for the methods which are not applicable for the online customers. So this is also termed as the interface pollution, which I have written here. Okay. So here we can observe a clear violation of the interface segregation principle, and the implementation classes for the telephonic customer and the walk-in customer will have unsupported methods, since the 5 methods are part of the restaurant interface. So you can say like any change in any of the methods of the restaurant interface will propagate to all the implementation classes. So maintenance of code then starts becoming really hazardous, and regression effects of changes will keep increasing. So restaurant interface.java also breaks the single responsibility principle, because the logic for the payments as well as the for the order placement is grouped together in a single interface. Okay, so it violates the single responsibility principle as well as the interface segregation principle. Okay, so what modification we can do? We can first of all, we can separate out the payment and order placement functionalities into two separate lean interfaces. Okay, so the first one is the order interface, and inside that we have kept the method as place order, and the second is payment interface. Inside that, pay for order. So after that, each customer will now implement both the interface. Okay, so there are three types of customers: online customer, walk-in customer, telephone customer. So all these three customers can implement this order interface and payment interface, these two interfaces, and they can override the place order method and pay for order method, and then they can write their own logics. Okay, so it will not violate the codes. So in case of that change in any one of the order interfaces does not affect the other. So similarly, in case of a change in any one of the payment interfaces does not affect the order. So they are independent now. Okay, so there will be no need to do any dummy implementation, and even there is no need to throw in any exception like unsupported operation exception, which we have thrown earlier. So it's not required. Okay, so this implementation classes have the proper implementations for that interfaces, and inside that only methods are there, right? So yeah, so basically in this way you can follow the other examples or other implementations as well. So you need to um, understand like what is the interface segregation principle. So then we can discuss about some frequently asked questions. So the first one is like interface segregation principle and single responsibility principle similarity. Okay, so this both the interface segregation principle so for the interface segregation principle and the single responsibility principle have approximately the same goal. Okay, which is like ensuring the small, focused, and highly cohesive um, uh, software components. But the different is like for the single responsibility principle, this is mainly concerned with the classes, while the interface segregation principle is concerned with the interfaces. So interface segregation principle is easy to understand and simple to follow, but identifying the distinct interfaces can sometimes be a challenge. Hence, we require careful considerations to avoid the expansion of interfaces. Therefore, while writing an interface, consider the possibility of implementation classes having different sets of behaviors. And if so, segregate the interface into multiple interfaces, and each will have the specific role. Okay. So in this way, this interface segregation principle and single responsibility principles are connected to each other. Okay. Then we can discuss about the benefits of the interface segregation principle. So what are the benefits? The benefits are like, first of all, one is it increased the code readability. Next is it's easier to implement. Next is it easier to maintain. Next is like better organization of code. Next is like don't need to throw exception unnecessarily, right? Then I also can discuss about what are the real world examples when ISP is crucial in Java development. So in Java development, like designing the Java libraries and frameworks where multiple classes may implement interfaces can be considered as a real world example of the interface segregation principle implementation. So it ensures that interfaces are granular and focused on specific functionality. So it also helps the library users implement only what is necessary for their use cases, and it also reducing the necessary code and dependencies. Okay. So what will be if we not follow ISP? So if we violate the ISP, it can lead to classes implementing methods they don't need, which can result in unreasonable classes. Okay. You can also see some interface pollution there. So it also increased the coupling and maintenance challenges. Okay, so it can also make it tougher to reuse the code, right? Next is like, what are the exceptions? Exceptions. What are the exceptions for the ISP? So while the interface segregation principle is generally admissible, so there may be situations where it's acceptable to violate it. So specifically, if adding separate interfaces introduces unnecessary complexity. So the key is to strike a balance between adhering to the principle and maintaining the simplicity. So these things are there. If you have any other questions, then you can also comment down in the comment section. Okay. So thanks for watching. And next we will discuss about the last part of this solid principle, which is the D. D means the dependency inversion principle. Okay, that things. Then we can also discuss some other questions as well. Thank you.